Alrighty. Good evening, everybody.
Hello!
First of all, I could not upload yesterday's episode to YouTube. I don't know why, but it just throughout the entire day, it keeps rejecting my video file. Um, so I can't even upload it. And that's never happened before, and I didn't change anything about my codecs, and the video file loads fine on my system, so I really don't know what's happening. YouTube is throwing a fit, so for now the archive is unfortunately inactive.
Condamne-moi.
Good evening, everybody. Hello, Jandril, Finn, and Eudoxia. Good to see you again. Anyway, as a quick reiteration, yesterday we did some work on autofilling. And today I spent a bit of time making it a bit better, a bit less stupid. So this time now we can just draw a thing and it'll do the needful. We can do a thing like this and then it crashes because it doesn't know how to deal with double walls and things like that. So yeah. Anyway, it's a bit better than before. And as you can see, it now fills the things in, but it's still a bit fragile because it doesn't know how to deal with a couple of cases. Yeah. Anyway, the way I did the innards this time was not with the onion skinning approach I showed yesterday. Instead, what I did was doing an implicit sign distance function by just doing an n-squared algorithm, where for every tile I want to fill in here, I simply test it against each border tile and take the smallest distance as the value of the sign distance function, which is good enough. It's n-squared, but whatever. This is an editor thing, and usually the amount of tiles to be considered is not that big, so I'm not too worried about it. Anyway, so this works pretty well now. Not seamlessly, but pretty well. Okay. Just wanted to show that off real quick. So, today is gonna be another different feature and still no UI toolkit stuff. I still have not managed to properly sit down and think through it, so we're not there yet. Yeah, so tonight we're gonna try and implement, or in the very least, start implementing an AI to automatically move characters along the 2D terrain. I have an idea on how to do that, but we'll listen to that in a second. Let me first get some music on. There we go. Okay, so as you know, my game is based on a tile approach, so we can express the terrain in this kind of pixel grid, or pixel graph, if you will. And our job now is to figure out how to move a character, say, along this, something like this. I don't know. Like, for instance, we say the character is standing over here, and we want to move them over there. And the system needs to figure out how to do that, and that includes jumping and all sorts of things like that. So the way I intend on dealing with this is by transforming the terrain.
Clearly it's time to teach some neural networks to play Leaf.
Oh yeah, definitely. No, what I intend on doing is to simply transform the terrain into a graph that we then can run a star on, and that's the basic idea. So we reduce the problem into two phases. The first is building this node graph, and the second one is already solved, or, well, yeah, solved for us by just running Dijkstra or a star or whatever you want. Okay, so how do we do this node graph transformation of the terrain? Well, the first idea I had was we can do this sort of in steps. The first step will be to identify different kinds of platforms that we have. And doing so is pretty easy, as far as I can tell. All we need to do is to go row by row and detect whether there's a pixel below us. And if there is, it's a platform. So something like this. Naturally, if you're an attentive reader, then this will already give us problems if we have something like this. In that case, it's going to do something like this. Now, I don't really consider that a problem per se, because this part here won't be able to be connected to anything else, and we'll get to that in a moment. So using this simple scanline approach, we can already form a node graph that allows us to walk on top of congruent platforms. Now, when we want to include dropping down, what we can do instead is to mark the edges of the nodes or of the parts in special colors or different kinds of nodes, whatever one have you. And let's also mark this one red because it can go either way. And then once we do the second phase, we simply look at all these edge nodes and try to connect them with nodes that are lying below and a pixel to the other side. So we move a one and then just scan along this column downwards until we find nodes that are below it, and then we add another connection there. So that way we can connect up falling nodes, I guess, or falling paths, edges. Finally, the jumping is the most difficult part of it, but I do have an idea for that as well. Namely, we first build a graph that tells us sort of what a jump looks like. So we start at a coordinate system of 0, 0, and then we calculate different jumping trajectories. So we could jump something like this, maybe, or we could jump like this, or we could jump like this, and so forth. So depending on the different kinds of velocities we have, we can use that to calculate different jump trajectories. And using this, we basically mark every pixel within reach of our jumping arcs and associate it with all the jump arcs that lead there. So we're going to need to calculate the arc itself, which pixels the arc touches, and do that for every possible point to get there. So for instance, if we're considering this point here, then we could get there with this kind of jump, or we could get there with this kind of jump maybe, or, you know. So there's two possible trajectories here, and using that, we can sort of do a reverse query of asking, if I'm standing here, which kind of trajectories allow me to go there? So using this backwards kind of information, we can then scan how do we get to this upper point here, and scan sort of where we can come from, or we can do the forward scan as well and ask from here, where can I jump from there? And again, for each of those, add a different kind of node edge to it, so that we know that in order to reach this next node, we have to take a jump with certain properties. So this kind of node graph thingy gives us then an easy interface to A star, and A star will tell us exactly which edges to traverse to get there the quickest, and then it's simply a matter of sort of evaluating these edges to get to the destination. Or in the very least, that's currently my idea of how things should work. This can all be done ahead of time in the editor or whatever, so it should be efficient as well, aside from the actual A star execution, which has to happen at runtime. Anyway, any questions? If not, then we're gonna move on to implementation.
I was getting food, but I assume you explained how you mean to create the trajectories.
You simply consider a couple of jump arcs and then trace the paths from there across the grid. That's it. So you might have like a jump arc, you know, that has 3 different horizontal velocities, and since the jumping strength is, well, we have 2 jumping strengths, so you would have those coupled together, and then just brute force iterate and collect the information.
So you create the jump arc options manually.
Well, yeah, how else would you do it?
Plots.
What do you mean plots? That's what we're gonna do. I'm not gonna like type in the numbers. Well, in any case, okay.
So you know that we out there, swatting lights in the naked.
This current model also doesn't consider slopes, which is another thing to watch out for. But I'm sure we can deal with that. It'll probably be like a different connection to get the slopes there. Or rather, if you have like a thing and then to the right of that are slopes, then you would simply immediately create a connection to the next platform to the right and up, I guess, or something like that. So you can't stop in between slopes, but anyway, let's first start with the simple stuff. So, first thing I have to actually look at is the right. So the information is upside down. Right. Okay.
And you know we were out there, swatting lights in the naked.
Let's see. Compute node graph. Solids. So again, first we go row by row. Let's actually make a separate function for this. God damn it. Just chill, birds, please. Right. this stuff again. How do we want to represent this? Hmm. Could actually use the flow library again, since we have different kinds of edges for that. And I believe I have a Dijkstra on that, so let's do that instead. Alright, so let's create a walk node, or a walk edge. Connection. And we're gonna have a fall edge. Which has to be a directed one. And a jump edge. Again is directed, and in this case we have a strength, I guess. And then we have different kinds of nodes. Platform node. I don't know what to call the possible movement options. I guess options? I don't know. Seems like a bad name. Do I have a port? No, not directly, apparently. Okay. Did I even do that? Should probably make a new package for this, but whatever. Okay. And then we have a edge node, or let's say, let's also add a position to this, or okay. Alrighty. Don't actually, well, should probably keep a table of the nodes. Let's see, we want a previous node, and which has to be nil up first. So if we have a new tile and we have a new previous node, then we create a new platform node. And we connected. I guess can do that in add node. Otherwise, or let's make this into a con actually. Alright, if there's no more and we did have a previous node, or if we did not have a... Wait, hold on, what? If we did have a previous node, then... Wait, type the node. If the previous node was a left edge node, then simply change class that into both edge node. Otherwise, if it is a platform node, then we into a right edge node. Okay. Actually, now that add node is only in here, I don't actually need to care. Okay, if we have a previous node, make instance. And the connection type needs to be a walk edge. Okay, that should be all. Now, well, not quite all. I still need to associate all the nodes on a grid. So we have a node grid as well, which is the same size as the solids. So we can stick all of those there. Whoops. Actually, I don't think I need to node a location in that case. Do I? Might be good to know later. Okay, and set of okay. No grid. Let's test it out. Let's again define a simple default map, test map, which is gonna look like I need to draw it upside down, which is a bit of a pain. Let's actually... Wait, something isn't right. Yeah, there's a... Okay. Feeds node graph. Width was 1, 2, 3, 4, 5, and the height was 1, 2, 7. Okay, that's really hard to visualize. Let's add a debugger. Node. What was it? The no case comes first, so this is just a space. And otherwise. Eh. I'm making things difficult for myself. Hmm. Not quite. This is bothering me. Oops. Also, hold on. If I start a new row, it should automatically clear it out. That's a problem I haven't considered. Why is that still marked? And why is that now a thing like that? Oh, I guess it's correctish. But why is that still marked? That's not right. What? Oh wait, it doesn't need to be 1 plus, it's just be y. So, you can also drop this case. There we go. Okay, that looks better. There we go. Alright. That is looking proper. Let's change this map up a bit to add hop like that, just to see that as well. Yes. Okay. Actually, no, wait, what? Why is that a thing and not a single hop? Oh, right. Because this also does not clear it. Essentially... There we go. Kind of. This one is wrong now. Why? Why is that wrong? Oh. Sorry. Oh, right, because we need to clear it after a row after all. Okay, yeah. Yeah, okay. That's not right. What? Well, I guess it is sort of right. Yeah, it's right enough. Okay, good. That takes care of the first part of this equation. So now that we have these nodes, we just need to go through the node grid again and look at all the edge nodes and yeah, should probably make this a okay, create Fall. Connections. Node grid with art. Okay. I should probably make a convenience macro for this iteration thing. With jump traversal, X, Y, with
You never see it come down. You see that my mind is too fast for eyes. You're done but the time it hit you, you're not surprised.
Wait, I don't even need access to it later.
Think you got your game planned out to a T, yet I'm 2 steps ahead, yeah. So step into my way, stand out. It's a trap, one step and you're dead. Why just a bit a second ago with blue skies, but now lightning
This
struck
doesn't allow me
It's that
to
and
do pro things though. Ugh. Yeah, so never mind it actually.
Catch it in time. Never think about your game. Are you sure your next move the right one for you? Are you sure you won't get
Okay. So we have a left edge node.
and my friend? You never see it coming. You see that my mind is too fast for eyes. You're done.
Actually, hold on. I can't convert into edge nodes if we have a wall there. So that ain't correct either. If or there we go. Now we're good. kind of. Why is this a thing now? Why is this not a double thing now? I'm confused. So, goes here, it makes a start, and moves to one to the right, and then this test fails, this test fails, and then it should have a left edge node. I don't understand why this doesn't convert. Huh? Doesn't really help, does it? Fuck, why does that happen? I really don't get it. It's not because there's a new row or anything, what? Left edge. Platform. Platform. Left edge. Right, so... I don't get it. Why isn't this a both edge node now? Oh. Because of the printing being wrong. Whoops. Yeah. Another case where printing was to blame. Okay. So now... loop for YY, and this time we have to go up from Y 0. No wait, what? 2. No wait, what? No. Hold on. We still have to go downwards, so down from Y to 0. When actually I still need an accessor for that. Okay. Wish I had a better way of printing these associations, like the actual edges between nodes, because currently I don't know how to do that. Oh. Wait, did nothing ever connect before? I'm confused. Wait, left edge node? We don't even have those. What? Oh, we have one of those. Okay, never mind. So, connection to that and to that, and I can't see shit because I don't know what is what. But it seems the falling is connected properly. Let's actually just print out the connections instead. That seems like a better idea, since that implicitly shows the type of connection used. Yeah. So a fall edge from here to the platform below, which is here. We have a walk edge from there to there probably. And then a walk edge from this platform node to this right edge to this, and then from both to the other sides. Okay, that looks correct. So Good. Good. Alright. Now for the difficult part, which is the jumping. Ah, boy. Let me quickly add some things to make this a bit easier on myself. Namely, where is this separated? Namely, I just want to add some debug stuff. 1, 2, 3, 4. Beautiful, isn't it? I hope that saved it correctly. Did it? It did. Okay. Now I want to make some tests to see what are the current jump stats. And to do this, I'm gonna actually should probably do this analytically by actually using the player's jump values, but I just want to see real quick. Long jump 7. Okay. Five for a hop, I guess. It's hard to do this with a keyboard. Yeah. Let's see, what current jump height do I even have? 1, 2, 3, 4. Hop is about 1 tile. Jump is 2 tiles. Okay. About seems right. Let's see what I can calculate analytically. How did physics work again? Because I forgot. Oh boy. I think it's also time we finally went ahead and got rid of this gravity hard coding. We grab Okay. Wait, actually, I should probably just make it like this. And I'm starting to sweat, because this week is gonna be hell. Let me actually check what the temperature is in Zurich right now. They claim it's 32 degrees. Nice. Yeah. How hot is it in my room? Hold on. My room's 26 and a half. So quite a bit cooler than outside. But yeah. Okay. 20 degrees sounds nice. I want that. How did I want to do this? Hold on for a second.
Where have you been? Been searching all along, confessing while alone and on, without a clue, without a sign, without grasping it. The real question to be asked: where have I been? I'm a sharpshooter. Masquerade, hiding both face and mind, all free for you to draw. I'm a sharpshooter. What else should I be? Please don't take off my mask, revealing dawn.
I mean, the easiest way of doing this will just be to discretize the jump arc, so basically plot it. But shouldn't there also be an analytical way of doing this? I'm sure there is, I just can't think.
Moments of calm, nothing left to be found. A mirror right in front of me. That's where I found an empty glass, reflecting that's a truth. It's telling page of bones, there's nothing inside. Will it unleash me, burning down the walls? Is there a way for me to break?
I think discretize is the easiest way to go, so let's just do that instead. Though I'm a bit confused at the moment, let me try to talk about what I'm confused about. So, assuming this, so what I need to do first of all, according to my proposed strategy, is calculating all possible jump targets. Now, it's a bit of a problem. I'm also not quite happy with how the falling stuff works right now, because consider having this, you know, something like this, or let's say more realistically something like this, where it would be possible for the player to fall over here, but currently the falling only considers nodes directly below, and we would have to instead consider things that are, well, farther away depending on distance and gravity, and that makes things more complicated. For the jumping, I'm also not quite sure, so let's assume I have this data structure built which for each reachable pixel within the vicinity of the player, so assuming the player is at 0, 0, then we're gonna have a data structure that is basically a lookup table for every point surrounding the player until a given cutoff that tells me how to get there, like what jumping arc I need to use. Okay, assuming I have this information, right? Assuming I've calculated this thing, how am I actually going to use it? Once I have this information. So if we're going back to calculating jump trajectories, how am I going to actually make use of that? I suppose the idea might be to just check at every edge node for every possible other node in the vicinity where we can connect it. So in the same size of this pre-calculated jump trajectory thingy. And then we calculate the difference and look it up in here. So for this one it will be 3 across and 2 up. So it will be this. And that gives us a list of jump trajectories, which we don't need to check for collisions, because in case there's something between, some of those trajectories are not going to work out. Okay. Mm-hmm. 12 degrees is a nice temperature. I like that. That's a good temperature. That's not cold. What are you talking about? You can talk to me about things being cold when it's -10 and you're on a bike going downhill. Alright. So I think that should work. Suppose though the first question is determining what the size of this data structure should be, and that's dependent on the current gravity and jumping constants. I'm not quite sure how to do that.
Check your acclimatization privilege.
Okay. Gravity, jump, and velocity, or, yeah. I don't actually know what the player's current constants are because it's kind of implemented differently in terms of accelerations instead of velocity is. It's also kind of questionable as to where to cut it off, really. Well, no, because there needs to be a lower bound, because, you know, you could make a jump like this. Wait, not like that quite, but maybe something like this, but then it would just, you know, go indefinitely. So at some point it needs to be cut off. And I don't know what it is. Man, I can't think right now, and that's bothersome. My brain is not doing any work. It's refusing. Please help. Somebody type in the code for me. I'm also trying to think about how to...
If you only consider the extremes of all your jump options, what kind of a plot would that project?
I'm not... You mean maximum jump strength and maximum velocity? Well, then you would only get two plots. One plot like this and one plot in the opposite direction. So really we only need to consider it in one direction since the other one is always mirrored. Or what do you mean? I'm not sure I follow what you mean.
No, I mean the extreme points you can possibly reach.
Yeah, but that's kind of the point, right? For negative y, there's no extreme point. Because it's just gonna go on indefinitely. We could calculate an extreme point if we say no negative y's, sure. Then it's obviously bounded. And there's a physics formula that I learned in high school that tells me how bounded it is, but I forgot. So I would have to look that up.
Yes, but what about other directions? Up, slightly upright, and so on. not the extreme landing point. The extreme point you can reach, then you know the area in which you can potentially land.
But there's no extreme... I don't follow. There's no extreme point. You're just gonna... because you don't have any platforms at all? The idea behind this is to enumerate all possible jumps you can make. So you iterate through the possible jump strengths and the possible horizontal velocities you can have, and then you plot all the jump arcs for that inside a given region. And for each pixel that you reach along that jump arc, you note the starting velocities you had for that jump, and also which pixels were touched along that arc. Does that make it clearer?
I don't think you still understood what I meant.
I don't. I really don't. I'm sorry, I don't know. What do you mean the extreme point you can reach? I don't know what you mean by that. Do you mean like the top of the jump arc? Or...
I'm drawing.
Ah, shit. Accidentally landed in a sea of piss. This stream is rated for adults only, by the way. No babs allowed. And now you know why. Cause babs are not allowed to see this. This is for I don't know what this is for.
Jumping into an ocean of piss, that's just the slogan for my life.
Gross, dude. quick speed Luigi. Yes. I still don't know what your point is, Gingy. Let me also show it on stream real quick so it's in the recording. Why does it
The
not?
top of the darker area forms a curve underneath which everything you can land on is.
Yeah, I know. But what's your point? That's... Also, the thing didn't disconnected. Good.
So my point is that you only have to figure out what that curve is rather than all the individual jump arcs.
Yes, but that would tell me which things are reachable, but it wouldn't tell me... Well, for one, it wouldn't tell me for a given point on here. It wouldn't tell me which configuration of velocities I need to get there. And it wouldn't tell me which blocks along the point are occluded by the jump arc taken to reach that point, or which kinds of options even I have. For instance, for this point, I have multiple options how to get there, you know. And some of those options might be viable and others might not be. So for instance, if there's a, you know, a block here, then only 2 of these options are going to be possible. So yeah, it seems easier to figure out what the bounds are, or at least, you know, cut off at some point, and then for each pixel in those bounds, or for each trajectory that we can make, record that information in the pixels, and then simply scan through for each edge point in the graph that we already have recorded, iterate through all other points, or actually, no, not for each edge point, for each platform point or edge point, calculate the possible edge points we can jump to based on this thing. On this cache, I guess. I mean, it's going to be bounded. But yeah. My current problem is knowing those bounds. Because I have stopped thinking. Also, I found a blog entry that implements almost pretty much the same thing as I do. And it's a part 1 with the author saying part 2 coming soon, but the blog entry is from 2015. Oh well. Okay. We could just We could make
Soon is
things.
very relative.
uh, we could make things easier, I guess, if we just don't consider dropping, but I don't want to do that. Kinda seems bad. Okay. What seems to be a sensible point? So we estimated that we can jump 7 wide. Let's just make it 10x and 10 in y. Why not? That seems okay, I guess. For now, just grudge. Okay. So we're gonna make 2 different jump strengths, I guess. Either, what do we have? 1 block high or 3 blocks high, I believe. One, two, three. No, only 2. Either. Wait, it's 1. No, 3. Yeah. Okay. So, actually, let's just do 3 steps, I guess. From 0 to 3. And then for velocity fractions, I guess. I guess we're gonna also do 3. Why not? 0 to. Wait, actually, can you even influence the jump speed or the vertical speed that well? Because there's almost no ground acceleration. It's more about air control, so whether you leave things on in the air.
Have you been searching all along, confessing while alone, without a clue, without a sign, without grasping it, the real question to be asked, where have I been?
Yeah, so we're gonna do none
I'm a
and
shepherd
2, 3, so that's 4, I guess.
outpost masquerade, hiding both face and mind, all free for you to draw. I'm a sharpshooter. What else should I be? Please don't take off my mask, revealing dawn. Moments of calm,
Okay. How many steps do we want to take? Well, 100 is probably more than enough. Let's see.
I'm a sharpshooter at post masquerade, heart in both face and mind, all free for you to draw. I'm a sharpshooter, chained down to my core. Please don't take off my mask, my place to hide.
So this is T times minus, or plus, I guess, JV times GTT. I think that's correct, since gravity is acceleration, so it's T squared. Yes, I think. Man, I sure wish I remembered anything at all I knew in school. That would be grand.
I'm a sharpshooter at post masquerade, hide in both face and mind, all free for you to draw. I'm a sharpshooter, have no face to show.
Round does not actually turn afloat. Oh, it does. Okay, nice. Good. Okay. Okay. Now TT obviously needs to be some other kind of dimension, or it needs to be more finely grained than this, depending on how these are sized. So maybe let's do this in seconds, I guess. I'm pretty sure 2 seconds is more than enough. Pi 0 point, let's do just 30 frames. Should be more than enough. Actually, yeah. could spin until we get a new X or a new Y. But I don't know. Let's just do it like this. It should also just be equal. Okay. Alright, jump grid. What did we have? Gravity. I wonder what the velocity is at the time I jump. And it changes throughout the jump arc too, so that's kind of annoying. Let's see. Where's the jump? Let's just see how this is. 2.8 is the max. About, okay. Very scientific methods, as you can see. And for the vertical, add a horizontal. We have, I think that's just a V-lim, isn't it? Let's see. Minus, no, it's no, V-lim is something different. Let's see. Weird. Minus 1.75. Okay. Oh, there it is. I think. Yeah. Maybe. No, not quite. I don't know. I forget how my stuff works, you know. Wait, what's here problem? This also doesn't collect new ones, so let me instead do something different. actually even better than what I had before. Okay. Interesting. Okay. So now we have that. That's good. Okay, so again, go through all the things. And for each of those, we go through all the platform trajectories and check whether we can reach it. Let's also actually change this into that. And this into the cons instead. Okay, good. Cool, Pulse Audio decided to put noise into my headphones again. Nice. Always appreciate when that happens. Actually, this is not correct as it is right now. I'm a dingleberry. Because this here is not quite correct. Assumes y is at 0. God, is it hot. I would like to get this step in the very least in, so that we have the node graph finished for tonight. And then I can worry about actually executing the node graph later. Or tomorrow, rather. Okay, when we have a thing, then... Wait. That's... Yeah, I guess if we have a thing, then we check whether we have a node at that position that we can jump to. Or a ref node. Grid. Plus JX.
Where is it? I don't do the path checking right now, but that's fine. That's okay. So this gives me absolutely no jump edges. Huh. Guessing I'm not covering enough? I'm not sure. But I'm unfortunately also out of time. So I'm guessing about 50% of the way there to making this, because I'm also quite unsure on how to actually execute this node graph. So once we've run a star and it tells us which nodes to traverse, how to actually make that happen in a, you know, in a natural manner, I'm guessing I'm gonna need to like figure something out for that, but that's gonna be another problem. Yeah. Anyway, some progress made. At least there's a plan. Start work on move to AI. And whenever there's a plan, I have a better time than when there's not. Alrighty, I'm gonna turn off my computer now because it's boiling hot in my room and I would like to not boil alive. Again, thanks to everyone for stopping by. I always appreciate it, and hope to see you tomorrow. And hopefully tomorrow we'll get to a point where we can actually see the AI in action. Yeah.
Good night, Shin.
Good night, everybody.